Hello, my name is Logan Tahi, and James Peters and Benjamin Keller and I decided to build a Newton's Cradle for our dynamics project. The law of impacts between bodies was first demonstrated by French physicist Abbé Mariotte in the 17th century. In 1967, English actor Simon Prebble actually coined the term Newton's Cradle. The largest cradle in the world was designed and constructed by Mythbusters and consisted of 5 one-ton concrete and steel rebar-filled buoys suspended from a steel truss with steel plates between each buoy to transfer the energy. The experiment didn't work out very well because of the inelastic properties of concrete. Much of the potential and kinetic energy of the system was lost due to friction and heat buildup within the concrete material of the buoys. Our goal was to build our own Newton's Cradle, determine our own coefficient of restitution for our steel ball bearings, and put in-class concepts to the test. Using wood, nails, ball bearings, string, and superglue, we built our Newton's Cradle. Using tick marks spaced every 15 degrees to gauge angular displacement, the group decided to consistently drop the first bearing 30 degrees from its resting point. One phone was used to record the collision of the bearings in slow motion, while the other phone was used as a timer. The purpose of recording was to use the phone's slow-motion camera in an effort to estimate the time the bearings took to swing the final 15 degrees. Going frame by frame, the group was able to attain these delta times and in turn obtain a angular velocity. To the bottom left, you see a schematic design of our Newton's Cradle developed on AutoCAD. To the right is the final product after construction. To the left, you see our setup we used when performing the experiment. You see the 2 phones used to capture slow motion and time, and to the right you see the paper attached to the back of the Newton's Cradle to gauge angular displacement. The following video is our experiment in action. To the top left, you will see the data obtained from 5 trial runs. To the right, you will see calculations and equations used to determine our coefficient of restitution, which we found to be 0.5227. According to Rod Cross, professor at the University of Sydney in Australia, the average coefficient is for steel ball bearings is 0.6. Our data was off because of the error we obtained from low precision equipment, human error, and human error. The following are our sources. Thank you.